welcome to Sparky Help, a YouTube web channel set up for electrical students currently covering electrical principles. However, if you've any requests for any other type of subject within electrical installations, whether it be cable calculations, how motors work, please get in contact, let me know. Otherwise, please enjoy the videos we've put on there so far. Wait for your comments. Okay, so here's a video that's been requested. This is a series parallel circuit. We don't know what the supply voltage is. We know what the current is flowing through the circuit. We know the three resistors, and obviously you may have noticed this is a series parallel circuit. And basically what you've got to do is work everything out about the circuit. So that's the voltage across each resistor, the current through each resistor, the power in each resistor, the total power, and obviously the one thing that's glaringly obvious is the voltage supply. So if you haven't already done it, pause the video, give it a go. Let's crack on. So what we can do is, we know at the moment we know the current coming out is 8, and we know this resistor. We know that the 8 amps passes through this resistor, so we can actually work out the voltage across this resistor, which I will call the V in R1. So to work out a voltage is I times R from Ohm's law. Well, which current? Well, as this is the current coming out, this has to be IT, or I supply, and we're going to multiply that by R1. So we put in these figures in, so that's 8 amps times 15, and that, if you do your calculation, is 120 volts. So we now know the voltage across this resistor here, just this resistor, is 120. Remember, it is not the voltage supply, because we've got a volt drop across this part as well. So we need to work other bits out. So this is the VR1. We'll call this one VR2. Because this is a parallel section, what we do know from parallel is that the voltage stays the same in parallel, but it won't be this voltage here because it's in series with this one. So to do this calculation, we'll call the V2, which is the voltage across this section here. Now that will be I times R. Now which I? Well, it's the only current we know at the moment is this 8 amps. And which R? Well, we know these two, but we can't use it at the moment, so we need to do other things before we do this. What we do know is 8 amps passing through all of that. Okay, so we will be using this I. Which R? Well, what we have to do is work out what these two resistors are in parallel. So we'll call this one R4, because it will be this bronze. Okay, so this is just that last piece broken down. So we want to find out R4, which is, remember, it's this parallel section. So for benefit for you guys, I have just drawn this bit, which is the parallel section in R4, which replaces it. So we're basically simplifying from a series parallel down into a simple series circuit. So we have to work out R4. Well, from the parallel section, so look at the parallel video for finding out how to do that. R4 is equal to 1 over R2 plus 1 over R3. And if we put the numbers in there, R2 was 8 ohms plus 1 over R3, which was 12 ohms. Remember, it is 1 over. So the button we use on here is 8 x to the minus 1 plus 12 x to the minus 1 equals x to the minus 1. Your answer is 4.8. So R4 is 4.8 ohms, which now takes us down to just 2 resistors for this whole series circuit. So if we want to work out RT for the entire circuit, now not our last for RT, but if we want to work out RT, it just becomes R1 plus R4. So RT becomes 19.8 ohms. Okay, so tidy it up a little bit. So we've got our voltage across this part here, Now voltage across both of these two resistors, because remember voltage stays the same in parallel, it's the current that splits. So current will come up, 8 amps comes up here, a current will flow through that, and a current will flow through that one there. So we'll call this one I1, and we'll call this one I2. So a simple one to start off with. Let's do power total. Power total then, for the entire circuit, there are 3 formulas to choose from. Look at the power video if you don't know what they are. I'll do V times I. So that for power total is going to be VS times IT. Okay, so because this is total, all these must be totals as well. So that'll be 158.4 times I total. Well, that has to be I total, and is times 8. And if you just multiply those out, so that will be 1,267.2 watts for the total of everything here. Now I've asked for everything else, so powering R1. So a formula I like to use for power often, I squared times R. So it will be the current flowing through that resistor, which happens to be IT, so just so we know, that's IT, times R1, so that will be 8 squared times 15. If we do that, 8 squared times 960 watts. Now we can do these ones here, the power in each of these parts. So we'll do the power in R2, just so we use all the formulas. Okay, we can do V squared over R. So because we want to find this power in this resistor, it will be the voltage across that resistor, so it's actually V2. And we want to find the power in that resistor, so that has to be R2. So putting those figures in, 38.4 squared divided by 8. And that then 184.32 watts in that one there. We could find the other power. For the other resistor, we could subtract these two from our total. Whatever's left will give you that power. But we want to find out these other two currents as well, so let's do those other two currents. So to find I1, we'll do this one here. So I1 is Ohm's law, so it's V divided by R. So to do that then, that will be the voltage across this resistor, which is 38.4, so that's V2, divided by R3 in this case. So that will be 38.4 divided by 12. .2 amps. So if 3.2 amps flows through this one here, Kirchhoff's current law tells us that the remainder must flow through the other part of the circuit. So therefore, I2 is equal to IT minus I1. So that will be 8 minus 3.2. And that will come to 4.8 amps. So we've got 3.2 flow here, 4.8 amps flow up the top there. So we can now find the power in that last resistor. Okay, that's it. That's everything you need to do for this particular circuit here. Lots of calculations, lots of knowledge, but practice makes perfect.